Welcome. In this example, we're going to be taking a look at using the sum and difference identities to rewrite our expressions in a single trigonometric function of one number, and then we're going to find the exact solution of the full expression. So let's consider the form of number 7 starting off. We have the sine of 13 times the cosine of another angle 32 plus the cosine of 13 sine of 32. So again, an interesting arrangement of sines and cosines. We could rewrite this in general as the sine of some angle A cosine B plus cosine A sine B. Now, you can take a moment to look at our sum and difference identities and see what form this is actually fitting. I'll give you a moment to do that, or you can pause the video. What identity is this actually representing in terms of sines and cosines for the sum and difference? What you would find, this is the form of a sine function, and it would be a sum. So this would be the arrangement of sine of A plus B. So the sum of sine angles. And notice that A in our expression is 13 degrees. And the B angle is 32 degrees for A and B. So when I rewrite this, I could rewrite this expression as sine of A is 13 plus 32, which is equal to the sine of 45. And then sine of 45, we got it down to one trig function in one number, and we can evaluate this and find its exact solution as the square root of 2 over 2. And that, number 7, would be solved. So again, we're using the sum of A plus B in the sine function. So let's take a look at the second expression and see if we can solve that one, number 8, using the sum and difference identities. We have the form of cosine of an angle A, cosine of an angle B, plus the sine of A again, which is 3 pi over 7, and then we see 2 pi over 21 again, so that's the sine of, we'll call it a second angle, B. Again, where our A and B angles are 3 pi sevenths and 2 pi over 21. So again, take a moment, see what identity we are working with. We have the product of cosines plus the product of sine functions. If you take a look at the identity list that we have, this will be a cosine and it will be a difference of cosines. So this would have the form of cosine of A minus B. So when I evaluate this expression, my A in this expression is 3 pi over 7, and my B is 2 pi over 21. So I can rewrite this expression as the cosine of A minus the cosine of B, which is the 2 pi over 21. So we're part of the way there. Now we just have to evaluate what type of angle this is, and then we'll evaluate into the cosine function. So if I wanted to add these two fractions, I'd want to take them to the same denominator. So the common denominator here is going to be 21. So I need to multiply this first expression by a 3 over 3. So I'll get the following that will have cosine of 9 pi over 21 minus 2 pi over 21, which gives us 7 pi over 21 as a total. Or we could just express that as cosine of pi over 3. And that final result, cosine of pi over 3, that's the same as the angle of 60 degrees. So that cosine is just going to give us 1 over 2. So there's our single function, and there is our final exact result, 1 over 2. Let's take a look at the last one together, involving a tangent function. Tangent of pi over 18 plus tangent of pi over 9 divided by 1 minus the tangent of pi over 18 again, tangent of pi over 9. So again, we can rewrite the form that this expression is in. That's the tangent of some angle A plus the tangent of an angle B divided by 1 minus the tangent of A again, tangent of B, where again, A and B are pi over 18 and pi over 9. So if we take a look at this general form here for the tangent, this is one of the tangents, either the sum or the difference. And if you do a double check here, you'll see that this is the sum of tangent A plus B. So this expression is really the same as tangent of A plus B overall. So we can evaluate this again with our A and our B angle. If I do a little bit of work to simplify A plus B, if this is my A and this is my B, we can do this as the tangent of pi over 18 plus pi over 9. And we know to get a common denominator here, we can just multiply that second fraction by 2 over 2. And we'll receive back that we have tangent of pi over 18 plus 2 pi over 18, which gives us a total of tangent of 3 pi over 18. But that 3 pi over 18 we can think about as just pi over 6. So this will go just down to a pi over 6. When I add those two together. So tangent of pi over 6, or tangent of 30 degrees here, is going to be the root 3 over 3. So that's our single expression right there, tangent of pi over 6, and there's our exact result, square root 3 over 3. So again, don't have to memorize those sum and difference identities, but just be able to recognize when you have them. So in our next example, we'll take a look, or the next video, we'll take a look at some more sum and difference identities.